Okay, folks.
So we will get started.
Okay, so this morning we had a more conceptual discussion. For the period after the morning tea, taking advantage of some of the refreshments. We will continue our hands-on examples, and I'm going to be doing an example that is custom made for this audience. I mean, a bit of ad lib, a lot of ad lib. It's all ad lib. But it's going to try to weave together several different aspects that people have inquired about. One of them is dynamic populations, population which is changing over time. Another aspect is the component of dynamic networks. So where we have networks changing in response to population dynamics, but also just in response to individual evolution. Now, I'm giving this so as to also cover the concept of events, and we're going to see events as kind of cameos in this presentation. They're going to come in, we're going to use them, and then at the very end, I'm going to talk more generally about two types of events supported in AnyLogic. Sort of standard explicit events and what are known as dynamic events. And we're going to talk about where they fit in. Both of them have great relevance to the area of open populations. And we'll come back and talk in more detail about the types of events, etc. Okay? So what I'd like you to do is to load in that model, minimalist network ABM model. We can build atop the model you built yesterday if you're feeling comfortable, or you can load in minimalist network ABM model, that example model provided. Okay, we've built atop this on other occasions. Those who have been building atop, keep on going. Those who would like it, I would go and get that off the list of examples. Okay. So that was, to be clear, that was the model we all built up together, but it is provided in case you would like recourse to a clean version of it. So thus far, we have introduced the basic mechanisms for creating populations of pre-specified sizes and creating networks from pre-specified set of network categories on that population. However, in realistic modeling tasks, open populations are the norm. By open, I mean they include vital processes such as birth and death, and processes such as immigration or immigration. Moreover, research suggests that many types of network dynamics, and I'd include here things like serial partnerships, differing contact durations, are important to contagion dynamics, to the spread of pathogen, and very likely to the spread of ideas, diffusion of innovations, etc. The choice of a static network is a weighty one. One should think carefully about whether or not to include dynamics in one's network, a network that changes over time. Fortunately, AnyLogic provides very strong support for adding and removing population members, adding and removing connections. It is hard to overexpress, ladies and gentlemen, the degree to which you are spared from the quite demanding rigors of software engineering to achieve such similar functionality as we'll be using today. You're riding atop AnyLogic's capacity to represent things with a minimal of mechanism, with great expressiveness, and you'll benefit from that. Just be aware that you are thereby avoiding a tremendous amount of additional work. However, that support is limited. For example, the aspect of network dynamics is something that is going to require a little bit of custom code. Let's just talk a little bit about how that's done in AnyLogic. If we have a population named in the main class, remember populations commonly live in the main class. if you do add underbar population name, you can add a person into the class. You could do that with no parameters, in which you just add someone with default characteristics as given by the population specification. Or you can actually provide parameters that explicitly specify the assumptions about the person who's to be introduced into the population. For example, specifying the perhaps their age, their ethnicity, or their sex, or what have you. Okay? We're going to be taking advantage of that. A second thing we could do is deleting for the population. And similarly, if you have a population name, we can do underbar remove or remove underbar population name, and pass it a reference to the agent to be removed, or remove that agent from that population. Okay, so here we can have populations where new members are introduced either through immigration or birth, or members are removed through immigration or death. Okay, for example. AnyLogic comparably provides methods for adding and deleting connections. So if we have a reference to an agent A, maybe it's this, and then a reference to an agent B, I can say A dot connect to B, and it will connect the two agents. Now note in AnyLogic, and this is something I would love to see provided as an option, but not enforced, but you'll notice that connections are assumed to be undirected and symmetric here. In other words, it's assumed that if A is connected to B, B is connected to A. And in many cases, that's what we want. In some cases, unidirectional connections are in fact desirable, as we know, but they're not directly supported. No, that means you can have them. There's no problem. It's just you have to keep track of that information yourself as to which direction a given connection will go. Okay? Similarly, we could say A dot disconnect from B. We have a reference to A and a reference to a person B. A reference to an agent A, a reference to an agent B. We could say A dot disconnect from B, in which case it disconnects each other. And again, they're assumed to be both disconnected from the other. Okay? You can see slides from the network lecture where my network's notes, which provide some additional methods. So I'm hoping you folks may have loaded in that model. I'd like to, yes. Oh, so it was provided to you? It's under example models, yeah. Oh. It's the U.S. Oh yeah, I'm sorry. It's not an AnyLogic model. It's a model that was provided on the USB stick. Apologies for that. The cruiser stick. Okay. So if you could load that model in. This is a model you may recall us building up. I think what I'm going to do, just to minimize, to make sure we're all very consistent, I actually have a copy that we built up together, but I think I'm going to myself go back to the original copy just to make sure we all have sort of a common base point. So it's called Minimal Network ABM Model, and I'm loading it in here. And what I'd suggest that you do is you save it away with a different name. So I'd call it Minimal Network ABM Model with open population. Okay, something along those lines. So that if you change it, it won't be something which destroys the original model. Okay, so. If we run this model that we've loaded in, we should see a fairly familiar site. So if we load it in here, we should see something like this. You recall that we did before, for those who just do want to build on your earlier one, which you're okay to do, you'll see colors of different sizes and so on. I'm just trying to speak to those who have loaded it back in. Those are the group I'm trying to keep in sync with here, okay? So that you'll see something like this. Those who are working off the model you built earlier, you'd see something like like this guy, I think. It would have things of different sizes and colors and oh gosh, oh well, for those who are working off the earlier model, please make use of a distance-based network. Where would that be defined? Where do we define the network type we want to impose on the population? Where does that information live? Environment. So we go to the environment, we go to the advanced tab, and you go down and you select the network type, and you should select it to be distance-based, and the layout type can be random. Okay. Okay, and that applies whether you load it in or continuing on. Okay, so I'm trying to start with a sort of common theme here. Okay, so what I'd like to do, the first thing I'd like to add in is immigration. Okay, and the way which we're going to add immigration is going to use a new construct, a new element of the AnyLogic vocabulary, which is called an event. Okay, and the key insight here is that we want to have people coming into the population over time, right? We want people to be introduced at a certain rate over time, rephrase it. So suppose we want 5 people to be entering this population per unit time. Well, if we'd like that, one of the best ways to do it, because that's something which doesn't affect one particular person, it affects the population as a whole, we can introduce an event. Now, where would that event live? The event is going to take care of kind of scheduling something for us. It takes care of making the schedule. The schedule can be fixed, or it can just be with a certain rate. Where would that event live? Would it be in Maine or the person? It's in Maine, because it has to do with the whole population as a whole. It's not for a particular person. We can have events for particular people, like scheduling their birthday or scheduling their successive events in their life. But we're going to drag an event in to Maine, and we're going to call it immigration event. Okay. I often like to have the word to the type of the thing, like event there, so that if I see the word, instead of just immigration, I don't know what sort of thing it is. I see immigration event, okay, this is an event. Okay, okay, so I have immigration event. You'll notice if we look at its properties, we have a whole bunch of choices, and I'll come back and talk a little bit more about these. But basically, we can have a one-time event, occurs once on either a timeout basis or a rate or a condition, or we can have an event that's cyclic. In other words, it occurs many times, not necessarily with equal timing between them. Interarrival time may vary. So we're going to make it a rate, okay, trigger type rate. And we'll have an rate of 5 per unit time. So make it a rate of 5, okay? What that means is there'll be a time of just 0.2 between individuals coming in. Okay. And if we just have this going off, nothing's going to really happen. It's going to wake up and the event will fire, come back, go to sleep again, wake up, etc. We've got to put something in the action, and this is where we're going to create a person. So we're going to use that thing we saw earlier, that mechanism we saw earlier, this add population name, providing any parameters associated with it, or we can simply use default parameters. Okay, so here's the immigration event. I can't remember here for this version of the model. I guess the person has no parameters right now. For this version I loaded in. For those who have built it up, you will have parameters. So here's his immigration event, and we can do add under bar population, and we'll just use the default parameters for now. Okay, so we'll add someone in with the standard distributions used to create the population. Okay. Now, if we wanted to provide explicit parameters like someone's income, we could draw it from a distribution here, because maybe the income distribution of immigrants is different than those who live in the population as a whole. If we want to provide their sex, we could do it here. But here we're just going to add them to the population with the default parameters, okay? So I'd like to run this model now. And when we run it, we will see nothing. In fact, we're seeing nothing at all. Okay, so something is off from what I expected. So this always makes these presentations interesting. So I'm going to go back to immigration event. Yeah, it should. Although AnyLogic. Oh, maybe it. Yeah, it's on the main. Okay, maybe I. Oh yeah. Okay, thank you. You have to. Unfortunately, Java is afflicted by cancer of the semicolon. Yeah. Yeah. Okay. Yes, I should. Oh, okay. Maybe I modified main for the other model. Thank you. I modified main for the other model. Okay. I was working in one model and running the other. Great. Okay. So I was running the model we had, the parallel model that we had before. Thank you. So this is immigration event. And this is a rate of 5. And this is add under bar population, like that. And I don't, AnyLogic is quite inconsistent. Sometimes semicolons are needed there, sometimes they're not. Sometimes they're provided automatically, sometimes not. So it's not a bad thing to include them for a statement. It'll spare you some, having it kick back at you. Okay, so here are people being added in. You'll notice, however, are the people being added in, are they located in the network? Okay, so we actually have to do a little bit more work to have it weave them into the network. But it turns out, in AnyLogic, in contrast to many environments, this is super easy. So if we go down to action, what we will have to do is we'll have to tell the environment, go figure. After adding the person, we have to tell the environment, hey, now go figure. Go add it in, okay? So the way we're going to have to do that is we're going to have to tell the environment by calling a method on it, environment dot. In other words, we're calling a method on the environment, and we'll say apply network. I'm doing control space, so it'll fill out for me, and it says discards all connections, establishes new connections according to current network settings. Okay, so we can do apply network here. And I'm just putting that after add population. Why after? Because we want it to recreate the network once that new person is there. Does that make sense to people? I'll go up and, I'm sorry, I'm being sloppy. I'm just going to put this up on the big screen. Oh, no, that. Here we go. There we go. So that's the code. This is going in the action place of the event, the action field of the event. That means when an event goes off, this action will take place. This is a handler for the event. When the event goes off, this is fired. Remember I told you yesterday, AnyLogic is driven by events. It handles each successive event. Each successive event will often do something, and sometimes that gives room for more events to happen. And it goes from event to event. Sometimes it's long periods of time between events, sometimes it's short periods of time between events. Here, we are doing add population and then apply network. We're asking the environment, go figure out your network again. Does that make sense to people? So let's run that. So we're going to run this in, and what you'll see now is people appearing. Are they being in the network now? Appearing in the network? Who needs help here? Okay. It's working with people? Okay, great. Okay, so we're weaving these people into the network. Now, taken to its limit, this would lead to an awfully overcrowded network landscape. So we're going to add in some vital processes. Some vital processes that will be allowing a sort of balance of sort to be to be worked out. Okay, so if we wanted to add a vital process in like birth and death, where do we do that? Where would we describe birth and death? Inside a person. Inside a person. So we're going to go to person. These things operate at a person level. It's a given person who dies and a given person who gives birth. So we're going to go down to person. Now, for those who are working with an existing model, you can actually create a new. You can follow along. I'll describe to you how without showing my cards yet. So, if we wanted to provide some sort of process that led to death, how do we do that? Sorry? Yeah, we can use a state chart to do that. If we wanted to have birth represented, how might we do that? Could have been invented in Maine, but it might be more general. See, the thing is, the characteristic of birth is the contrast with immigration. For immigration, we might have a fixed immigration rate, like 5 people per community. But for birth, the number of births that occur depends on what? The number of women, the number of people who can give birth. And so we could put it in Maine, but then we'd have to somehow be reasoning about, okay, how many people can give birth? In an agent-based model, where we typically put it is in a person. Because a given person has a certain chance, say, of giving birth over time. Now, there's any number of different ways that we could do this. One way would be to have an event at the individual level that's a birth rate event. And when that fires, so it goes off with a certain birth rate, and when it fires, an individual is brought into existence. Or we could have a state chart. We could have a state chart represents the period of pregnancy, and then a subsequent delivery. Which of those would people be more interested in seeing? Any preference? An event? Okay, great. We also will need to have a death going on, and one of the ways we could do that is with a event. The event fires with a certain chance, or we could do it with a state chart. I think I'll do that with a state chart. Okay, so we'll have a state chart for sort of live status. Status, and when we'll have living category here, that will be one component, and then we'll have a final state which is associated with death, and there'll be a transition between them. Okay, I'm doing this partly to rehearse state charts. I'm doing this partly because some of you who have already built a model may want to use your existing state charts. Now, if you have an existing state chart, you might even want to push your luck and have a hierarchical state chart. A state chart where one state is embedded, like the existing states are embedded in another state, and then you have an exit from there. That's common to both those states, but I'm not going to elaborate on that now. So we have a living state, so they come in and they're living, and then they die. Okay, so let's put into place this death first. If I wanted to have the death event occur, I want the person to be, say, eliminated from the population. Where would I do that? So okay, it'd be associated with this transition. They could be eliminated from the population. Alternatively, I could put it on the entry point to this final state. Maybe this final state is called dead, in contrast to the living state above. And maybe this transition is called death, right? And and I'll show the name here, so we can drag it down here. And this transition will occur at perhaps a certain mortality rate, right? Now we could hard code that mortality rate here. In other words, we could just put it in, say a mortality rate of 0.05. Okay, that's a pretty high mortality rate. But we're gonna put that in there. So here we have a very simple state chart. Again, if you have an existing state chart, you could just create one like this parallel to it. Alternatively, you might use a hierarchical state chart and have one transition out to death, which would therefore be from either the susceptible or the infected state, whatever state they're in, they leave. But it might be easier for you to just do a parallel state chart like this, okay? Okay? Now, at the time death occurs, we're going to have to undertake an action. What action are we going to do? What are we going to undertake here? Anyone? Remove. We're going to remove this person. Now, there's something you got to learn here that's going to follow you in many cases. This person has to remove themselves, but it's actually main who's going to take care of removing them, because the population, they have to essentially ask the population to remove them. We didn't have to worry about that with immigration because that was occurring in Maine. This is occurring in person, and we're going to have to ask Maine, hey, remove us from the population. Remove us from your record of the population. So we're going to have to delegate this to Maine. So we're going to have to somehow get a reference to Maine and then say, hey, remove us from the population, okay? So we're going to have to see how to do that. And that's in general useful because we might need other information from Maine. For example, we might want to get a parameter from Maine or get some count of people infected across the entire population from Maine. So for this action, we're going to have to write something which uses remove population. It's going to be something like this, remove population. And remember, when we have remove population, we have to tell it who to remove, the agent to be removed. How do I denote me in Java? How do I say me? This. So we're going to have to say remove population of this. But there's a fly in the ointment because we have to ask main to do it. If we tried to build this, we'd get an error message over here in the build window, and I'm going to have to find it. Here it is. It says method remove population is undefined for population. In other words, it says it doesn't know what to do with that. In other words, it doesn't understand what we're trying to do. We have to ask main to do this. So fortunately, if I know myself, I can ask myself, hey, get the main associated with me. Get main. And that will give me a reference to main. And then I can just ask main, hey, remove the population. So let me copy this code to a place that you can see it. By the way, I just built, and this said build completed successfully. So I know that's working. By the way, notice in this case, AnyLogic does not require a semicolon, but I'm going to put it in just for good measure. Here it is. This dot get me. So this is a reference to me, and I'm saying, hey, me, what's your main? Give me a reference to your main, you know? And so I click this dot get main, begin paren end parentheses. It's a method calling a function on it, and that will return a reference to the main class. Now I've got to kind of reference that, and then I can say, hey, main, remove me from your population, and it will say yes, and do my bidding. So here we are asking main to remove us from the population. Does that make sense to people? Successively, this is a reference to me. I'm saying, okay, get my main, get the main associated with me. And I'll say, oh, my main is that one over there. Hey, remove me from your population. It says yes, and then I get removed. But we won't do that to the end of the workshop. Okay, so that would be an unfortunate side effect. Okay, so does that make sense to people? Okay, so can we run this thing now? Let's run it, ladies and gentlemen. So if we go and we say run, okay, here we have people coming in, but we also have people leaving. Can you see that? Okay. So here we have a population that's changing over time. Who needs help here? Oh, help? Oh, okay. Help. Okay. So, folks, out of the bear pit and into the world. Okay, so when I put these things up, these dots are significant. I know that from a distance they may look like commas or semicolons or what have you, but those dots have great importance in Java. It's, again, conceptually it's like an apostrophe. It's saying sort of, this is get main. I'm going to call this as get main, and on that that's returning a reference to the main class, and then I'm going to instance the main class, and then I'm going to call remove population on it. So reading it from left to right is how you read that. You start and you ignore the later stuff at first. You look at this and you say, okay, this dot get main, okay, that returns something, and then I call this some other thing on that. It's called fluent style, actually, is the name for it in coding style. But that's how that works, and those are dots. Okay? Yes. Okay. So it's a good question. The issue is you don't actually have to write this dot. If you don't say okay, in AnyLogic, if you ask for a method, okay, all calls to function in AnyLogic have to be in Java have to be done on something. Okay, you have to either call it on an object, or you call it on a class, but you're requesting something to do the work. Okay, so conceptually, there's always a dot method name call. Okay, so if you have a method name call like B, or F with parentheses there, that's calling it on something. Now, if you don't specify what to call it on, you just said get main, then by default it's on this. Okay, it's like it substitutes that in this dot implicitly there. Okay, and that's really what happens in the Java compiler. It says, oh, that's missing. Okay, I just put that in there. So in fact, I don't have to write that out. However, I find students get confused about that, and so it's just clearer to put this dot get main. But to be honest, I'm being sloppy about this from time to time. You will find me lapsing. For example, in our immigration event here, here I just said add population. Really, that is what that means. Okay, this dot means me, add population. But if I don't say to whom to send this method, I'm by default sending it to myself. It's like if you hear me make an utterance and no one's around, it's like I'm talking to myself by default. Does that make sense? Okay. Yes. That's a good question. So you could put it in the final state, or you can put it in the transition. It could be an entry to the final state of the transition. The aesthetics will differ between that. I kind of don't have a strong viewpoint on that. In other words, it could be I have put it associated with this transition. So there's an action when this transition occurs. And conceptually, I think of that as the death event, so it should occur there. But it could be upon entry into this state that it occurs. And if I had many transitions into this state from many places elsewhere, it would just be easier to put it one place. It just put it upon entry to that state instead of putting it for each of those transitions separately. Does that make sense? Well, so I'm not sure I'm getting your question properly, but I could take, if I wanted to, with no change of functionality here, I could take that out of here and I could put it in the action associated with this thing here. And that would confer benefit if I had lots of other transitions coming in here and they were all death transitions. I handle them in one place. Does that make sense? Okay. Okay, other question. Is there still trouble up here? No, okay. It was the capitalization. Yeah. Questions? Help? Okay. Yeah. So once you're gone. So I'm not going to wade into theological arguments here, but it is true that this agent hangs around. So yes, you could add yourself to a different population right after this, for example. So for example, I could say, this dot get main dot add heavenly population, or something like that. Actually, yes. So I could add. I actually would be adding somebody with my characteristics, but it actually wouldn't be. I can't say add this to that population. I could just say add someone with my characteristics, which it's something we may get to when we talk about hierarchical modeling. But yes, there's actually, this sticks around for a little bit. It's true. But it wouldn't be counted in the size of the population. After this is removed from the population size is going to go down. Okay? Does that make sense? Okay. So any other question there right now? Yes? Sorry? No. Well, yes, viewed from an aggregate level, but let's be clear about this. So each person in the population, each person that's out there, so if I go up to look at this population while it's running, right? And if I were to freeze it at a given point, and if I were to drill down here, I see this person's here, and what this is telling me is actually their death is scheduled to occur at year 26.783. That's when they're scheduled. That's when they're scheduled for, and unless some other event happens which prevents them from going there, that's when they're scheduled for. This other person will be 21, 17, etc. The point is that actually it's 17 from now, I think. The point is that each person here is responsible for sort of their own, whether or not they die and when they die. And it's true at an aggregate level. You could think, okay, random people disappearing, but from the point of view of a given person, they have a certain probability distribution associated with the length of time till they die. They're in fact, there's an exponential residence time associated with this state in this case, because they have a certain kick at the can for every successive year. That's just because we had a fixed rate. It doesn't have to be a fixed rate. It could be a rate that varies by their age, etc., the mortality rate. But the point is that each person here is independent of one another, so there is a sort of random selection of who dies first. I don't know. Am I answering your question? Okay. Other question? Okay, let's add birth in. So there's several ways we could do it. We could do it with an event at the individual level, or we could do it with a so we could add in a birth event if we wanted to, or we could do it here with a recurrent transition. So while they're living, they while they're in this state, there's an event which is occurring with a certain probability that would be birth, and that could occur with a certain rate, and perhaps the rate is I don't know 0.04 or something somewhat less than the mortality. Take into account the immigration coming in. So here birth would be going off. This birth transition will be firing off periodically with this certain rate, okay? And how are we going to add people to the population? So when a birth occurs, how do we add the baby to the population? Okay, so we have to do it in Maine. And we saw how we added something to the population before because we did it for immigration, right? We actually go up to Maine, and then who do we ask we actually, well, we're going to have to ask Maine to add it, and then we're going to have to ask the environment to add them into the network, right? So here, for our actions, we're going to have to do this. So what we're eventually going to do is add population, to add the baby to the population. Again, if we had wanted particular characteristics of the baby, so they're age 0 initially or whatever, we'd specify it here. But we're going to have to we want to do add population, but that's something that's Maine's job. We don't know how to do it. Maine is the person who maintains the population, or the entity that maintains the population. So we need to do this dot get underbar Maine. That gets reference to Maine. And then we have to do add population. And then, well, what else do we have to do? Who remembers? We have to do the network. So how would we do that? Remember how we did it up before in Maine? We had this immigration event, right? We had this immigration event, and we had environment.apply network. I'll tell you, what I was really doing is I said this dot environment. That's really what that meant. My environment, get my environment, and then now that I've got a reference to that, say apply network. So how are we going to translate this into the context of person? What do we have to write here to have that apply the network? Can anyone tell me? Get main dot environment. Because that get Maine here, that first part of this, will get a reference to Maine. And when we were up in Maine, all we have to do is say this, and that's a reference to Maine. But here, we're down in person, and the person is down here within the environment. We have to say, okay, get my Maine, now I'm at Maine. And then I say, okay, my environment, and then, get my environment and apply the network. So here we have to go up to the Maine level. We're getting the reference to Maine and then adding the environment. That's why up in Maine we just had to say this, because we already had a reference to Maine, and so we could just call it environment. Does that make sense? People? Does that make sense? Questions? Yes?
My question is whether birth only applies to one portion of the population, in this case females.
Good. So let's show how that would be realized in a bit. Okay. Yes.
So probably more conceptually, for instance, we put something in the main which has add the person.
Yes.
So why do we have to structurally enable part of the person's level here rather than somehow just all the existing or whatever else?
Oh, so you're saying, like, why do we have to do both of these here?
In a sense, kind of one that encapsulated
Yes.
At the level
Well,
of population,
you,
we can add buildings end-to-end, we can cover.
yeah. Well, I have to tell you, I like your question because my very sense of aesthetic revolts against what we're doing right now. As a software engineer, I stand before you remiss. I stand before you polluting your mind with unhealthy coding habits. But I try to take one step at a time. It's just like we're teaching a baby how to walk. I may be a track coach, but I'm not going to critique the baby's, posture and stance and say you gotta get down and prepare to run. That you're moving your foot in an improper way or something like that. I want to lead it along on my finger without troubling it with the vagaries of track physiology. But this is violently against my sense of aesthetics. My students at home would probably be ashamed if they saw me doing this. So, what could I do to do this better? Well, we'll show you in a minute. I will show you how it could be done much more cleanly. Okay. But for now, let us walk. So I'm going to run this. And what we will see now is, it's horrible. So here we're having people added through immigration, and we're actually adding them through births. Births are occurring. Now, how do I have confidence births are actually occurring here? Let's go give a bit of information. So when that birth occurs, when this birth occurs, I'm selecting this. Let's actually print out something that will say, okay, a baby was born. We can even give the baby's name, okay? So we're going to say person P equals this. Now we're giving a name. We're saying this add population, it actually returns a reference to a particular person. We'll actually have this reference to this person. We'll have the baby, a reference to the baby, and then we'll go down and trace ln. We'll say a baby was born, and its name is P, okay? This is a reference to the baby, and when we put it in this thing here, when we concatenate it with this string, it will now print out its name after, its name, its name is P. Does that make sense? We're gonna do this. We're just gonna check if the babies are being born. Sorry, let me. So I'm putting traceln. Traceln is your friend. It's going to be one of the key ways of outputting to the console. There'll be other ways we'll highlight things in red and so on. But this is what it says. Traceln. This is double quote, not two single quotes, but a double quote. A baby was born. Its name is, and then end quote, and then plus P. Okay. Okay. Oh, and sorry, folks. I did modify this line as well. I'll put the whole thing here. Now this is abusive. We'll clean this up in a bit from a software engineering standpoint. Person P equals that. So we're getting a reference. That person P. This add population was being called before, and it just threw away what it returned. Now we're actually remembering it, and we're referring to it later. This is declaring what's called a variable. It says there's a variable called P, and it's a reference to a person with a capital P. So that's how we kind of remember it. And we have this variable. Now we can refer to this thing. So we could have now this baby. And actually, instead of calling it P, we should call it person baby. And put it something like that if we wanted to. That's a baby. It's a reference to the baby. So by calling it baby, we know it's not a reference to a mom, for example. It's a reference to the baby. So it just helps us remember what it's a reference to. I don't know if you folks think I'm crazy or what, but okay, that's fine. Whatever you think is what you think. Okay, so moving right along. So let's run this thing, and hopefully we'll have some joyous events announced. So here we are, and look at that. Look at the names I've chosen for those babies. So a baby is born, its name is root.population 101, 102, 103. It's adding them to the successive populations. So and you'll notice like sometimes it adds them with the same name. So this baby the first baby who died there may have died, and then it added another one. The point is, sorry. Okay. So here we're having babies born, babies living and changing over time. Okay, so this is a dynamic population. Now let's deal with Roberta's question. Suppose we want to make it so that this birth was contingent on sex, so it could only occur to females, right? Okay, so first we have to distinguish sex of people. This gets into the world of enums again. For those who are using the pre-existing model, I'm sorely tempted to use the same thing, but I think I'm going to spare that. So if you're using your pre-existing model, just watch. Okay, I'm not gonna. It's actually really easy to do with this, and maybe I'll comment on it, but I just don't want to confuse everyone by imposing enums right now. So I'm going to impose a parameter called sex for those who don't already have it. This sex, I'm actually going to call it is male, okay, and it's going to be Boolean. Alternatively, I could have made it 1 or 0, as is the convention in biostats, okay? Or actually, I'll call it is female, sorry. Is female. It would just be, the logic will be a bit clearer. Is female will be Boolean, true or false, okay? And now birth. Do you remember I told you once when I have a transition, how can I make it so it only fires under certain situations? Can anyone remember? It's a guard. So the guard here will be that it's female. Okay, the mother is female. So I'm only going to give birth if I'm female. That's one way to do it. Another way, ladies and gentlemen, would be to have a split in the state chart. So be one set of processes relevant to men and one set of processes relevant to women. Another possibility is you have 2 different types of agents, a female agent and a male agent. Any of those would be viable as a strategy. There's actually a number of other ways to do it. But this is one way, and so now we're going to have only the females give birth. And how am I going to verify that? Well, I could have it print out the status of the mother. So here I could say, and the mom's name is this. That's the mom's name. And is female equals, and I'm going to say is female. So now I'm printing out further information here. I'm printing out information on the status of the mom. So the joyous message is going to include the mom's identity, which is generally something included in a birth notice. So a baby was born. Its name is this should say baby. It should say baby. And the mom's name is this. Do you see why this is the mom's name? It's the one who fires that event. And is female equals the mom's is female status is female. Okay. I just put that in there just to be so I could show you that only females are giving birth, which is something sometimes required to gain a measure of confidence in a model. Okay. So I'm going to run this now, and we'll see this. Okay, it's in Unhappy Camper. So let's go see what's going on. Oh, I didn't. I changed it in the thing I was showing. This is called baby, not P. Okay, good. So we're now a happy camper. It says when I press this build, it says build completed successfully. So it's happy, and now I can go run this, and various messages will be printed out here on the. Oh, look at that! I'm not getting nothing. Why not? Why not? Why am I not getting anything? That is the thing. So I defined it as part of personhood, but I haven't said what it is in that population of interest. So where do I have to tell what it is in my population of interest? Where would I go to do that? Where would I go? Where's the characteristics of the population of interest, like previously income and sex and so on? Where's that defined? Sorry? It's in main and population, this population here. Remember that? And actually we could specify it either in parameters, or we could specify it here in general. I'm going to specify it in parameters, and I'm going to do random true with 0.5 probability for them being female. Okay, so I went up to main, I went to the population, and went to parameters, and I set female to be random true with 0.5. Does that make sense? Does that make sense? Okay. Okay, so now I'm going to run this. So now some people are going to be males and some are females here. And look, babies are being born again. The mom, so the baby was born, it's root population 98, and the mom's name is root population 77, it is female is true. So now all of these is female is true, okay? So now, in all cases, the mom is female. Yes? Lynn? Yes. You could do that. So yes, it is possible. Yeah, yeah. So when they come into existence, you could determine their sex from reading from a database. You could. It's cleaner to do at the main level to have the sort of data read in and create them at that point in the population. But sometimes we do essentially what you do. Like if I showed you something where I keep track of their age, I'm tempted to do that. I have about half an hour right now, and I'm tempted to either do network dynamics or keep track of their age. Sure. Sure. Well, it's readily possible. It's straightforward to do. Good. I think we'll maybe. I'm sorely tempted to do age here, but I think I'll leave that for now. When I want to hit the network dynamics. Okay. Maybe we'll come back and do age at some later point. Yeah. Yeah. Correct. Yep. Correct. 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 Yeah. Yes. Correct. 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 Well, to be clear here, this apply network, we're using it as a convenience here because people are adding in, and we don't want to be bothered figuring out whether they're connected to different people in the population. We just want it to take care of it. We could always when that baby is born, we could explicitly say, okay, your connections are so. Or when a person comes into the population, we could always say, okay, they're located at this position, they're connected with these other people. So we always have the option of doing that. It's just the apply network is a convenience that we can use in certain cases, but in others it's contraindicated, and you end up manually adding in. For those who are interested in capturing demographics, capturing age as continuous variable, capturing birth, capturing wiring of babies into the mom's network, keeping track of who a mom's children are, or who the children's mother is, that sort of stuff. There's a model that I've distributed called ABM model with birth death, which you can open up, and it includes all those processes, which you might or might not be interested in. Okay. but that is a sort of more fulsome depiction of demographics. Okay? Okay, so I'm going to build on this, though, this model. So ABM model with birth death is your friend. I want to build on this model, though, to deal with this issue dynamics. Okay, so what I am going to do is to have a situation where individuals get have a certain number of partners at any given time, and over time they add new partners or they lose partners. Okay. And we could do this with a state chart. We could do it with events. Because someone had wanted to see events at the person level, I think I'll do it with an event. But rest assured, it can be done like so many things in AnyLogic in several different ways. So I'm going to go down to the person level here, and then I'm going to add in an event which is new partnership, okay, and I'm going to add in an event which is loss of partnership. Probably to be symmetric, I should have it be gain of partnership, loss of partnership. So maybe I'll change that to gain partnership, loss, gain of partnership, loss of partnership. Okay. Right. What I'm going to do here is to when someone gains a partner, they're going to add in the partner to the list of connections. When they lose a partnership, it will be deleted from their connections. So the first one we'll do is loss of partnership. Okay. Here what I'm going to do is to delete connections between themselves and others. Now, I'm thinking about this as a distance-based model, which we're going to have to change because that's implied by distance. But every time we reapply the network, it'll force people to have this certain set of partners. But we'll come to that. So loss. Why don't we first, before I do this, let's go over to main, and I'm going to change this network type to be something different. I'm going to change it to be, let's say, a small world network. Okay, pursuant to Mike's interest. So network type, we're going to make it small world. Okay, and we'll have each person connected to an average, say, of say 5 people per agent, and a neighborhood link fraction be 95%. So most be located near them conceptually. Okay. So I'm changing the network type to be small world, and I'm going to arrange it in a ring. Okay. People are going to be arranged in a ring. Okay. So I'd like to actually run the model right now just to see what it looks like as a ring configuration and with a small network. And then we will, so this is what it looks like. And the problem is right now, okay, yeah, it's recalculating. Okay, this is not working well with the sort of previous example because we're applying this network. Okay, I think what I'm going to do to do this cleanly, I'm going to go back. I asked you to save this under a different name, so I'm going to go back to the original model, and then we'll do it off the original model, just so I don't have to worry about immigration going on at the same time and so on, which adds some complexity. We could do it, within the time it would be tough. So I'm going to go load in again this earlier model we loaded in. So first close this model we've been working on, okay? Close it up, this one with birth death, and I want to load in the model, that same model, ABM model with a minimalist network ABM model. Okay, I apologize. It's cleaner to do if we're working from that model. So minimalist network ABM model. Okay. So if you could put that back in, that would be great. and that will let us have a clean slate on which to do things, where we don't have to worry about networks being applied. Okay. Okay, so again, just running this so we see what's involved. If we run it, we see. Oh, okay. Oh gosh, did I modify? Did I modify that? Okay. Oh, I have the immigration event here. Okay, great. I actually, looks like I actually did override it. Okay, I'm gonna get rid of this this thing, the birth. Okay, yeah. So it looks like I had not saved it separately. Okay, so now I'm going to run it and just make sure it's as expected. Okay. So I think I will ask everyone to go to that environment and do it in a ring lattice network. So we're all consistent here. So ring lattice network with so ring lattice layout and small world network. Okay. And again, the connections per agent should be 5. Neighborhood link fraction should be 5. Okay. Hmm? Connections per agent is 5. Neighborhood links fraction is 0.95. Yeah. Okay. So, if you run it, you should see something like this guy here. Like that. Do you see that? Okay. Do people need me to go back and show what I did? Okay, for the environment, I set it to be 5 connections per agent. I set it to be ring layout type, small world network, connections per agent 5, neighborhood link fraction 0.95. Okay? Okay. So now for a person, I'm going to add 2 events in. One is called gain of partnership. One is called loss of partnership. Okay. So now we're working on a cleaner slate. So gain of partnership, loss of partnership. And the gain of partnership is basically going to increase the number of connections we have, and the loss of partnership is going to decrease the number of connections that we have. Okay. If there are connections to be deleted. Okay. So gain of partnership, we're going to add someone in, a randomly selected person from the population in. So this is an event going off of the individual level. I'm going to do it with a certain rate, and I'm going to add a parameter called rate of partnership loss, okay? And I'm going to add another event called well, I think I'll have another parameter called number sort of how shall I put it? Connection count eventual or something like that. It'll be sort of their eventual connection count. Okay, so they're going to go up to a certain level, and so this rate of partnership. Okay, right, rate of partnership loss in connection count eventual. Okay, so we're going to have a gain of partnership and a loss of partnership. Let's do loss of partnership first. For this, we're going to have a rate, and the rate is going to be dictated just by the parameter, rate of partnership loss, except it's going to apply for every partnership that we have. We're going to have a certain rate of partnership loss. So in other words, this is going to be a rate per connection, or a chance per unit time per connection that that we're going to be losing a connection. So this actually needs to be multiplied times my number of connections. This get connections number. Okay. So here I'm going to have a rate of losing partnerships, a loss of a single partnership, that's the rate of partnership loss, the per partnership rate of loss, I guess I should say, times my connection number, okay? So each of my connections has a certain chance per month of dissolving, basically. And so if I want to figure out how frequently I lose any connections, my number of connections times this per month chance a given connection will dissolve. I should probably label these more cleanly. So that's the loss of partnerships. And when that happens, I'm going to delete one of my connections to somebody else. Okay? I'm going to delete a connection to somebody to whom I'm connected. So I'm going to do this delete, and I'm forgetting the syntax here. It's this dot disconnect from, and I'm going to disconnect from one of my connections, okay? So which one of my connections am I going to disconnect from? Well, I'm going to pick randomly from my connections, amongst my connections, okay? So I am going to have to figure out, okay, which connection number do I wish to delete, and then delete the connection with that person, okay? So there's going to be a little bit of mechanism involved. This dot disconnect from, and I'm going to draw a number that's a uniform from a uniform discrete distribution between 0 and the number of connections I have minus 1. This dot get connections number minus 1. So if I have one connection, it's clear which one has to be deleted. It's number 0. If I have two connections, I either delete number 0 or number 1, and I'm going to pick between them with equal likelihood. Okay. If I have 3 connections, I'm going to pick between 0, 1, and 2 with equal likelihood. So to make this clearer, and I'll put it up above, I'm going to divide this into several lines. So I'm going to say int I connection to delete. So this is going to be the connection number to delete. I'll put this up on a thing here. So I'll see if I can make this larger so you can see this. So this thing here, I'm naming a variable called connection to delete. This is 0, 1, or 2, or 3. It's an integer. And I'm going to set it equal to this. This is a draw from a probability distribution, a uniform discrete distribution between 0 and my number of connection numbers minus 1. Minus 1 because it goes from 0, 1, 2, 3, in which case there'd be 4 connections. 0 by itself is 1 connection. 2, if I have 2 connections, it goes from 0 to 1. So it has to be this dot get connections number minus 1. So here I'm picking the connection number to dissolve, okay? And then I'm going to disconnect from that person. This connection to delete, I'm going to have it this dot disconnect from, and I'm going to say that get connected agent at that index, okay? So those are the 2 lines here that you'll be needing. So you can put spaces between them if it's clear. Unfortunately, the font size spread this out over 2 lines, so I'm gonna make it slightly smaller here. Okay, so there we go. It's still not fitting on one line, so I'll go up here. Okay, yeah. Oh. Yeah, there we go. Okay, that's better. Okay, so this first line draws a number from a discrete distribution between 0 and the number of connections minus 1. That's because we label everything starting at 0. 1 connection, it's just 0 to 0. 2 connections, 0 to 1. So it's minus 1 here. By the way, you can put a space here if it makes it simpler and makes it nicer to look at. And then I'm going to call this, that's me, disconnect me from the agent who's at that position, okay? So I picked my position to dissolve randomly. So that's the code for that. Any questions about that code?
Are these two events independent of each other? Losing connections and gaining connections?
They're assumed to be independent of each other in this model we're creating here. There's much more sophisticated models. If you look at Morris and Kretschmar's work, they have a very nice model, partnership, dissolution, and attachment, which you could look at. This is just a sort of proof of concept model. But I think it's actually, I thought this through, and I don't think it's totally crazy, okay? But normally, gain of a loss of partnership, if what you're referring to, often follows the gain of a different partnership, or vice versa. Okay, so loss of partnership, here we have this deletion, and here we're going to have a gain of partnership we're going to do. But let's run it with loss of partnership first. So with loss of partnership, we should see partners leaving over time. So let's go run this thing, and here we'll be running it, and so far we haven't seen any loss of partners. Oh, sorry, I didn't. Oh, thank you. Thank you. The rate of partnership loss. Thank you. Yes, quite right. Okay, so where do we set that parameter? In the population, right? In the population. Okay, so for the population under parameters, for rate of partnership loss, let's make it, I don't know, 5%, something like that. So there's a 5% chance per time unit a given partnership will dissolve, okay? Okay, so I'm going to build this, and now we see partnerships dissolving. People see that? People need help? Okay, so this is code, and now we're seeing partnerships dissolve. I went and I set the rate of partnership dissolution by default to be 5%, okay? I set that for the population, and now we have this partnership loss. Okay, so now let's have partnership, now we're going to have this connection count eventual. Now I wish I had a way to describe this better than on this. I wish I had a blackboard. But basically, folks, we're going to have, if we have a count of connections right now of C, okay, and we have a per connection chance of being dissolved for a given time unit of call it P, and call it mu, then this is how many connections we have lost per time unit on average, right? So if we have C connections. Now, if we have a rate of creation of connections of alpha, so we have a chance alpha, a new connection will be created per unit time. We have alpha created per unit time on average. The situation where these two are equal, where we'll be in balance, is a situation where C equals alpha divided by mu, okay? So at C equals alpha divided by mu, at that special situation, the rate of dissolution of partnerships, which depends on the number of connections I have plus the chance per connection of dissolution. The number of connections I have lose per time unit will equal the number of connections I get per time unit. It's at this point here. And that's what we're specifying in this other parameter, connection to eventual. That's kind of our equilibrium number of connections. I put that in as a parameter because that's the sort of data you might have from epidemiological study, how many connections people have at a given snapshot of time. Okay, so we have specified the partnership loss, that's mu. And now we just need to specify alpha. Alpha here equals C times mu, okay? So if we have C, that's the other parameter here, connection count eventual, alpha has got to be equal. To get this count as our kind of eventual count will be if mu is too large then an alpha is out of balance with mu. Mu is too large. Partnerships will be dissolving. The number of partnerships will come down until the number of the number of partnerships lost per unit time equals the number of partnership gains. So if mu is too small, the number of connections will build up. In other words, if we're dissolving partnerships very slowly compared to how much we're gaining them, we're going to be building up our number of connections until we have a number where the number left per unit time equals the number coming in per unit time. So this alpha here is this rate of loss of this rate of gain of partnership. So in short, we're going to compute this to be rate of partnership loss, rate of partnership loss times the connection count eventual. That's sort of our equilibrium. If we go far enough out, those are the number of connections we'll have. Okay, so how are we going to add a partnership to somebody? How are we going to do that? Well, I gave the description of how to do it. A, connect with B. So we're going to connect ourselves with a randomly chosen person from the network. Okay. So I'm obscuring some small details, like making sure we're not going to try to double connect ourselves, but I'll gloss over that for now. So I'm going to have this dot connect to, and I'm going to pick a random person from the network. Okay. I can't remember if environment supports that as an automatic thing. Get. I don't think it does. Let's see. This dot get. I'm just gonna experiment with something. Dot environment dot get yes, it does. Get random agent. So we're gonna get a random agent from the environment. We're gonna connect to it. So let me put that code up here. So I'm specifically answering Bjorn's question about how do you have sort of change in partnerships to capture heterogeneity in epidemiological data. And this would be one way to do it. This dot connect to, so this is in the code for gain of partnership. This dot connect to, this dot get main dot environment dot random agent. Let's parse this out. I'm saying, hey, I connect to somebody. Who is it I connect to? It's this person specified here in the parameters, from this parameter to that one. I'm just passing a parameter. What is this parameter? Well, I get the reference to my main, I get a reference to the environment, and then from that I say, give me a random agent. So it gives me back a random agent. Now, there may be an issue here if that agent is to ourself, and I'm going to have to check that. That may cause an issue. But this is the code I'm putting in right now, and we'll see if it causes an issue, because some chance we'll get to ourselves, in which case we could keep on going until it's not someone. It could also be someone we're already connected to. Okay. Okay, so I'm putting this in for now, and then with this as a rate of partnership loss times count of connection count eventual. So this is going to allow people to have a connection count eventual as measured by epidemiological data. And then we'll just have to specify rate of partnership loss, and then we could get people with very different numbers of connections in equilibrium. So I'm going to run this thing. It's closing in on lunchtime, and I don't want to keep people. But I'm going to run this. We forgot to specify the connection count eventual. So connection count eventual, I'm going to draw it. Okay, I need to go to this. I need to draw that from some distribution. And for now, I think I will draw it from a uniform discrete distribution between, say, 1 and 30, something like that. Between, say, 5 and 30. So here, each person will be associated with an eventual number of connections that they'll have if we run the model out far enough on average. And we're going to have people gaining partnerships. Okay, yeah, cannot connect an agent to itself. Fine, fine, fine. Let me go back and tweak my code. So that's what I feared. Gain of partnership. Okay. So all we're going to have to do is loop until we get someone we can connect to that's not ourselves and it's not someone we're already connected to. So while true, you folks don't have to follow this along until this, if you don't want to. While true, I'm going to get a candidate person P candidate, and it's going to be a person that I get randomly from the population. And if P candidate is not equal to myself, and if this dot is connected to, if I'm not connected to the candidate, in that case, then I'll connect to them. Otherwise, and then I'll right, this dot connect to and break. Otherwise, I'll continue on. Just trying to think. This could be done more nicely if this were up in the. So we could put it like this, and this is a little bit better. Otherwise, there we go. No, better yet. Do while is. I don't think. Oh, yeah. Do. This is better. That's nicer. Okay. Oh, isn't that a thing of beauty? Okay. It's exhibiting. Okay, pre-candidate. Yeah. Fine. Okay. So person pre-candidate. There we go. Okay. It's still exhibiting. Exhibiting displeasure. Let's go see. What's the matter there? Okay, so this guy here, why is it unhappy? Come on. Okay. So it's not. Okay, type mismatch. Oh, yeah. Okay. So I have to cast this to a person. Fine. Okay, good. Okay, so let me put this thing of beauty up for you. And then you can decide if you want to do it. Okay. So what this is doing, this code. So I wrote some code, and this is example why you want someone without a knowledge on hand. Okay, so the problem that we had before is we had some code that tried to connect this to a random matrix, and it's one final piece of code. So then we have to connect to that person, P candidate. So before we had a problem because we picked a random person from the population and tried to connect to it, and it said, because sometimes that person is us. We try to connect to us, and it said, nope, you can't connect to yourself. And I didn't want to connect to someone who was already a connection of us, too. So I wrote this code. Basically, what's going to happen is we're going to draw a person from the population randomly. And then we're going to check if, gosh, this is, because I moved things around, this is, that needs to be corrected. Okay, as long as this person that's drawn from the population is either us or someone we're connected to, we keep on going, drawing another person. Once we got someone who's not us, and it's not someone we're already connected to, then we connect to them. That's a bit rich, I know. So we declare a variable for a candidate. We say, okay, we're going to draw a candidate person to connect to from a random person from the population. Then we're going to check, is this person good enough? Is it someone that's either us or it's someone we're connected to? And as long as it is, we're going to draw it again. And then finally, when we find someone, it's not us, It's not someone we're connected to, then we connect to that person. And so with that, I'm going to paste that in, and we'll just run it. And we'll see a model where some people are building up connections, some people are losing connections over time, and we're going to have a fair degree of heterogeneity in terms of number of counts. This is someone with a connection count eventual that's fairly large, 24. This is one with 13, it's smaller. And if you'll notice here over time, this person is changing partners over time. Some of their partnerships are being lost, some are being gained, and over time they're connecting to different people. This is someone who's very large, 15, etc. So, in short, here, folks, we have a way of having partnership dissolution and partnership gain that yields a distribution where people eventually have a number of partners as specified by the sort of average number of partners within the population that they have. So here's 22, for example. Here's 10. Oh, this already finished. 9. Someone with 9, etc. They keep on changing partners. So Bjorn, that's an example of a changing partnership network. Dissolution and formation. Here, the key things I'd like everyone to take away, well, probably a lot of this went over your head. Disconnect from, you can disconnect from another agent, and you can connect from an agent, or connect to an agent. Those are your two key things for causing dynamics within the population, okay? Dynamics of connections. So you can delete connections, you can add connections, and this is a fairly sophisticated way of having dynamic network that's changing over time with keeping a certain average number of connections, which varies per person. Okay? Okay, I've gone too long though. Yeah.
We have to finish, sorry.
Yeah, no, it's just that.
No, I know, but can you talk to me about it?
I'm just hoping that he saves it. And,
Oh, yeah,
maybe
of course,
I'll answer
of course,
something.
of course.
Yeah, I'll provide it to the group here.
Yeah, we'll give
Yeah.
it to you.
Yep.
That's given. Thanks for reminding me anyway, but as I say, caterers are got to keep a few people happy. Remember, there's a public lecture at 1 o'clock back, a little bit early. I believe this will open the door, but I'll test it. Which way to start?